Thank you all for coming. And as Bert mentioned, this is a coalition. Like, this hasn't been just kind of, one person doing this, one person doing that. I mean, we definitely had a lot of push from our state representatives. You saw Kilmer, Mark Elias, Brian Blake, Steve Theringer, Brian Hatfield have all been very instrumental in moving this forward for us on that side of things. And then, to get the code changed, we had AIA Washington, we had Joe Mayo with Malum, we had the American Wood Council that went and helped change the code there. Woodworks, obviously, we're the Wood Education Group. Susan Jones was involved in that. And what's pretty exciting about that is we, changed the code here in Washington, and then I started getting a bunch of phone calls from different jurisdictions of like, hey, how did that happen? How can we do that? And so if you've not seen that, the work that we did here in Washington has now been copied by Utah, and Utah has now adopted the tall wood buildings. City of Denver took the exact same information, and now City of Denver allows the tall wood buildings. So there's a lot of work that Washington did here that then was taken to other places and literally copied and pasted in the other jurisdictions. So it's been an exciting effort to move everything forward. We've also, on the manufacturing side of things, it's pretty exciting too. As Bert alluded to, when the committees in Forterra, one of them is workforce development, one's for capital incentives, one's for, education. We've got a whole bunch of committees, and with that, Forterra has set up operations in Spokane. Russ Vaughan has set up operations in Spokane, is utilizing the east side wood of Washington in his product. So it's an exciting time to be here. We've got clients like Microsoft that are pursuing this now. You got Walmart that's pursuing this now. You've got Amazon pursuing this now. So there's definitely a lot of large interest. There's a lot of small interest. And I do love that Derek mentioned the brewery blocks. It's a great building. Horizon Partners did that. But he was like, oh, that's the tallest building, and it technically currently is in Washington, but you'll be surprised at the people here today that are already pursuing. You'll see the speakers today that are already pursuing and already in for permit on taller buildings, so that's pretty exciting. And so with that, Woodworks, we're a nonprofit, we're a nationwide organization tasked with providing free technical assistance on wood buildings. That's our job. And some people know me as the one that accidentally started the tall wood buildings. I was just trying to show that we had the engineers, we had the architects that could do these, and I set up a performance-based process at the state of Oregon to permit framework and to permit carbon 12, which became our new type 4C, our new type 4B building, and then Brock Commons became our type 4A building out of British Columbia. And it was pretty exciting setting up this event because we had originally lined up a lot of speakers from Canada, from Chicago, places like that. And all of a sudden we started looking at it, and the tide has turned. There's like all the speakers today you will see are Washington local. We have now the expertise here, we have the projects here, and we're showcasing what we're actually doing here in Washington today. So with that, we had the state produce SB 5450 that created I don't think required the State Building Code Council to take action is the right word, but maybe suggested that the State Building Code Council take action. And at first they're kind of like, hey, what does this mean? And then they actually got very excited. They were very interested in pursuing this. They were proactive. It wasn't reactionary. So it was a very good, again, collaborative effort to modify the state building code to then adopt the tall wood language. So we had 91-6 in the House. It's a statewide change. We originally were trying to run this through Seattle. Seattle didn't want to be on the hook or liable for a statewide amendment, so we then ran it through the state. But it came directly from the ICC committee. And so with that ICC committee, that's the steel industry, that's the concrete industry, that's the wood industry. And so to see these tall wood buildings basically get past other materials that are typically not happy to see wood in their arena is a pretty exciting place to be. And to realize this code has not changed like this since 1910. Let that sink in. The Model T Ford car was the vehicle in 1910. So this is the first time this code has been changed to that extent. So it's a pretty exciting place to be. And so with that, Washington, we got that approved in July 2019. There was 4 public hearings down in Olympia with, again, people from Forterra attending, people from the State Building Code Council obviously listening to our argument, and a pretty exciting place. And what most people may not understand is, so That's currently adopted today statewide in Washington. And so that's today, 2019, you can do this. Most people in the ICC, that's the 2021 language, and there's typically a 2-year delay on adoption on that. So even though it's in the 2021 language, most jurisdictions won't adopt it till 2023. So here we are, 2019, we're 4 years ahead of the rest of the country for the most part. Again, there are jurisdictions adopting it, but typically it's a 2-year delay. So that's an exciting place to be. And then, Joe actually also got that modified for the 2018 IBC, and then it'll just roll right into the 2021 IBC as we move along. And the good thing is, and what I caution people is the woodwork side of thing, what happens with me is I go into a lot of people's offices and it's like, okay, this code's changed, it's great. The framework of the code has changed, but there's still a lot of devil in the details to be worked out. And day in and day out, I sit down like, well, what do we do here? And I'm like, I don't know. It's like, let's figure it out. Because the framework, the building heights and areas have changed, but it's like, okay, well, how does this, glazing interface with the floor? And so you'll hear people talk today about, the issues that they're seeing, how they're addressing them, and you'll hear that from several speakers throughout the day today. And so here's where we came from. When I was trying to, we sent some reverse trade missions over to Europe. They saw all these tall wood buildings. They came back and they're like, why can't we do this out of mass timber? And light frame, specifically in Seattle since the 90s has had 5/2. So you could do 7 stories of light frame construction, where the building code will limit you to 6 stories out of mass timber. And mass timber is more wood fiber, costs more money. So why would you build a mass timber building when you can go 7 stories with light frame that's less expensive? Didn't make sense. So this is where we got to. This is Brock Commons in British Columbia, 18 stories, 270 feet. This is Framework in Portland, 12 stories, 180 feet. And here is Carbon 12 in Portland, 9 stories, 85 feet. So don't believe the 9 stories. The business occupancy lets you go 9 stories, but only 85 feet. Who wants that? No one. So again, on this committee to develop, so basically we took these prototype buildings, they developed nationwide language on it through the ICC committee that was comprised of the steel industry, the concrete industry, and the wood industry. So again, there are some hiccups in here that the concrete industry fought tooth and nail to limit this. So this originally was going to try and be 9 stories, 96 feet, but they capped us at 85. But they let us have the 9 stories. So there are things in there that don't jive, but it is what it is. And then we didn't touch the traditional type 4 heavy timber that could do the 6 stories. We literally just introduced 3 new construction types. And if you've not seen it, Matthias is here, DLR Group. We wrote a book with DLR Group and Fastenep and Swinnerton. And basically, I will tell people that we actually looked at this building and we did things that you wouldn't try and do in a traditional square wood product building. So this has a nice S shape on the front of it. It's got the 2-story atrium. It's got a green roof on it and everything, and still priced out 0.5% less than a post-tension concrete building. So again, we did things that were not friendly to wood to make it not pencil, and it still did pencil out. And so this is an example of a project in downtown Seattle, right on Denny Park there. And there's quite a few more popping up. So even though this isn't happening right now, because the developer's waiting till the next economic cycle, we have 3 already in for permit in this realm. And so with that, we have speakers today, and on this panel to kind of go through the practical considerations, like what have we run into here. And so Troy is going to speak on the JTM construction side of things and what they're seeing. Chris Patano is going to speak on Patano Studio. He's done a lot of work in the mass timber arena, has built a DLT building in South Lake Union. Dean Lewis is with DCI, is that what we're saying today? And DCI engineers, and he's going to talk about some of the engineering work that's gone on. So with that, I'm going to let Chris start it off and kind of give a short overview of what he's been seeing.
Thanks, Ethan. Thanks, everybody, for attending this morning's session. Our firm has really focused and with a laser-like intensity on this mass timber movement. It's core to our beliefs, and we honed that message with this notion of building nature. And we really see the relationship between where our building materials come from and how we implement them and what that means for our local communities and environment. And similar to the representative's message, I grew up in a small logging town in North Idaho. And on the river that I grew up on, there were 7 logging mills when I was a kid, and there are 0 now. And I really felt that mission as to trying to figure out a better mousetrap. How can we take this resource that we have surrounding us and implement it in cutting-edge architecture? As Ethan mentioned, we did construct the first DLT building in Seattle. It's on South Lake Union, a perfect prototype building. It was a small office building over a marina where there was a fire, and so we had an amazing site to work on above a marina and to stage the construction of a DLT structure. This building, it actually is very straightforward, but the thing that we were very excited about is we use this building as a module to scale up from 1 floor to multiple floors. And we found that the technologies to go from the 1 floor to the 6 floors, it's just a repetitive system that you can implement. The structure is very straightforward. You can move up a level. The fireproofing, the codes, the glazing, all the systems really, it's very module-driven and repetitive and easy to work with. This project has a large office space, some back of house. Our mission was to highlight the wood, the DLT panels. My directive to our structural engineer is I want to see this wood roof fly. So there's only 2 beams, 2 beam lines within the building, and the DLT continues to the exterior to create the solar shading to the south and to the east. We have a few images of the installation. We wanted to make this a little more difficult, so we decided to do it over water with a barge, just to see how that would go. So we shipped the DLT panels down from StructureCraft. We staged them on North Lake Union, hired a barge company, brought them over. Once we got the barge and the crane aligned, we picked the first panel. The first panel took about an hour and a half to set because, of course, it was 8 feet wide and 38 feet long. But once we got that set and square, the rest of the panels went in about 3.5 to 4 hours. So what we had blocked out 2 days for, we got the first panel in about 10:30 in the morning, and we were done by 2 in the afternoon. So that was a great surprise and relief. The building code official from the city of Seattle had blocked out 2 days because they were very interested to see how this went together, and we kind of all looked at each other at 2 and we're like, well, what should we go do? Because that's done. So it speaks to the modularity. It speaks to the precision of the materials that are delivered. And with a good install crew, the speed that can be accomplished in construction. And Ethan and I were in a meeting yesterday, and when you start penciling out and working on larger projects, the speed and the schedule reductions are really in our favor for mass timber projects.
Awesome. Thanks, Chris. Thank you, everybody, for having me here today. I'm Dean Lewis with DCI Engineers. We are structural consultants. The one thing I'll say for DCI is we have about 13 offices across the U.S., mostly in the West Coast, and then a couple in the Midwest, in Austin, Texas, and Denver. And what I can say is from all those offices in the past couple of years, we've seen a major influx in the amount of mass timber projects that we have. We have about 60 projects currently in design or construction, and that's using all different types of mass timber. That's the CLT, NLT, DLT, and even the new player MPP. And so it's been quite the awakening for us and realizing the potential in all those different markets. They have different supply chain considerations and a lot of different cities having jurisdictions with their own interpretations of the code. Beyond DCI, you can obviously see, and Ethan's talked about the wave that's coming across the nation. And there's still some challenges for us, but it wasn't as bad as 4 or 5 years ago. I recall trying to get into the city and having a building that used CLT. There were some jurisdictions that were very standoffish, especially in California, Washington, Oregon, more progressive. But I remember when Structural came out with their first ICC report, that was, getting passed all around because no one had one yet. And now we've come a long ways in terms of structural testing and fire testing to the point where we're not really operating at a disadvantage anymore. And soon, with these new codes, going to be operating at an advantage. And what I mean by that is the structural impacts. So currently, for our codes here in Seattle or Washington and Oregon, we're designing under a lower seismic force. Essentially, what has happened is the United States Geological Survey has gone out for the past few years and collected data. And from that data from seismic activity, they've determined that our probability of exceedance, of which we design a building for to make sure that it's safe, has been not as significant as it needs to be. So therefore, come July, in Portland and Seattle, and this is actually already hit in California, so we're already seeing this, you're gonna have to design for higher seismic forces. And so you can see on that slide there, I know engineers love, nice graphs and a lot of numbers, but essentially for a building under 85 feet in the Seattle region, and this depends on where you're located, if you're in even softer soils, it can have emblematic effects, but generally about 20% increase in your seismic force. And that's independent of what building type you are, concrete, steel, timber, what have you. It gets even more significant if you look at taller structures. So we're talking now the 12 and 18-story structures. You're looking at anywhere from a 60 to 80% increase in your seismic forces. And so that's going to give mass timber a huge advantage moving in the future. Instead of what we were looking at 4 or 5 years ago, where we didn't have the testing to back this up, we didn't have the product, development. Now we have suppliers in the state. So looking at an example, it's pretty simple. Force equals mass times acceleration. The mass of the building, that's whatever steel, concrete, timber. That acceleration is the seismic event, put hypothetically, and so therefore the force that we have to design for is much greater. So where Ethan showed off that 12-story building, which is an amazing cost study, and it was penciling out pretty much even, now we might be pushing the needle a little bit more towards a mass timber building. So, and there's other challenges there with CLT shear walls that are considered for certain building types or CLT diaphragms, which we can talk about later.
Great. Thank you. I'm Troy Blodell. I'm with JTM Construction. We're located in Seattle. And we're a locally owned and operated commercial general contractor. Pretty much all of our work is done for developers and to building for a pro forma and to a budget, so to speak. So I put together some slides I was going to share with you today on kind of how we analyze mass timber buildings, but maybe it's a little bit of a different perspective because we look at it first as a high rise, and then how would you apply mass timber to it? On a personal note, I'm born and bred Washingtonian, grew up down here in Tacoma, went to school in South Tacoma, started my construction career just down here on 26th and Jefferson for a mechanical contractor. So it's great to be back here. I love coming down. We've done several projects. I've been involved in several projects in Tacoma. It's a great community, and thanks for having us down. As I say, you got to just start somewhere. So when we budget buildings, we use typically a systems format, especially early on in kind of analyzing the costs. And we call it systems because buildings have a variety of systems. There's elevators, we call those conveying systems. There's interior construction is a system. Site work, furnishings, these kinds of things. So this is a snapshot of a commercial project. It's about a 10-story building that we're working on in Seattle, just to give you some perspective. It's core and shell office. We don't have time today to kind of go into all of the different, high-rise, residential, that kind of thing. But pretty much all the work we do is downtown corridor, either Seattle, Bellevue, as it relates to high-rise, and so forth. So the systems, when we analyze mass timber, the systems that are really primarily affected are the superstructure. And that's where you get into that kind of general concrete, steel, mass timber discussion. Exterior closure, how is the building enclosed, and then how is the interior built out, and then there's some what we call general requirements that go with it. And the general requirements are those things that cost money that I often say owners never like to pay for, but it's the cranes and the temporary protection and things like that to support the cost of construction. The superstructure this is a good picture. What you see here, superstructure is it's the columns, the beams, the decks, and the floors. And when we study these buildings, we've looked at it, for comparison to cast-in-place concrete and steel, as you heard Ethan talk about. Those are kind of the traditional. If you're going to build a high-rise, pretty much the go-to system's always been concrete and steel because primarily of the, I guess the change in that is the recent code revisions and a couple other things I'm going to talk about. But with the mass timber, it's interesting when you get over about 6 floors, the feedback we're getting is that we're now looking at a hybrid lateral system. So the wood systems now need support for a lateral shear wall or brace frame or something like that. And this is an older slide, so sorry, but so lateral systems would be like your concrete core, concrete shear wall, steel brace frame, something like that. So when we analyze them, we have to kind of pre-plan them and price them out with kind of both of those systems configured. And I think from just a dumb general contractor's perspective, the mass timber is a lot like steel. I mean, it's pieces and parts and connections and details like that. So it tends to get pre-planned and coordinated kind of in that vein. The enclosure is just everything that encloses the building. There's a lot of different options. So when we're analyzing mass timber, there's really no reason that there should be a cost premium or necessarily a cost efficiency with an exterior closure. They coordinate very well with the mass timber building. I think the main consideration, our takeaway, is that there's some constructability sequencing issues that are important as it relates to bringing the building up kind of together so that you can manage weather and keep the building dry as you build the building. On the interior, I think there's opportunities here on the interior because really one of the opportunities with mass timber is you want the mass timber and the structure to kind of express itself. So there's an inherent savings in there to not have to build out a lot of traditional interior systems. So it kind of lends you to really need to look at a mass timber building differently than a conventional office because you want to consider a lot of these open kind of environments. The mass timber is the structure, that's what you're dealing with, and so that kind of drives you into wanting to think about pre-planning of where do you route systems and where do you route the systems and how do you prefabricate those kinds of elements into the glulam beams and the CLT panels. So that leads us to really in high rise, and this is a nice parallel with the mass timber design, is you really need to maximize virtual design and construction because you're really looking at an integrated approach to how we pre-plan these projects. If we're going to erect a panel, we have to route a pipe through it. We want to have that drilled or prepped or whatever off-site, so it shows up on site and we can just erect it and move on. There's, sourcing has been an issue, but I think what I'm seeing is that there's 4, 5, or 6, depending on the timing of your project, regional suppliers. And so that's a game changer, I think, for commercial construction, is that we can go out and talk to 3, 4, or 5 suppliers about the timing of our project, the cost, and options. What I've found when talking to them is they're all a little different in terms of how they do their offerings and the types of products they make and their ability to do certain levels of prefabrication or off-site storage and things like that. And that because we're working kind of in downtown sites, everything is we call just-in-time delivery. So whatever this mass timber is, it's got to show up on the truck, get erected, and then bolted into place. And it has to be good to go kind of at that point, just because we're picking 70, 100 items a day. So we really maximize the off-site prefabrication, which also lends itself really well with the virtual design and construction. Fire protection during construction is an issue with high-rises in general. In any high-rise, you have to provide temporary water for fire in the event of a fire to fight it. There's a code requirement with the mass timber that we need to wrap the underside of every 4th floor during construction. So if you wrap it with GWB, it's water sensitive, so we need to have a game plan for keeping that dry as you work your way up through the building. So weather protection is a factor as you kind of consider this. This is a slide we put in here from our friends at Clark Barnes. It talks about the standpipes, talks about the temporary water supply, and then this is a nice little pictorial that identifies it as you bring the building up, in this case a 12-story building, at this 4th and 8th floor intervals, there's going to be some kind of a barrier there. Ethan and I have talked about this. It's not it's not a particularly new idea in high rises. We do this, we call it bathtub construction as an example. You've all seen, 40-story buildings go up, and we do temporary protection for very similar reasons, but for weather protection. So we'll have a concrete floor, we'll bathtub it to the exterior closure, run pipes up so water can collect there and we can pump it out, but it keeps the floors below dry. An application or a means and method similar to that would be something we'd probably look at to solve this kind of a problem, to keep the drywall dry and kind of keep the interior building as you go. But what it does kind of tell you or connotate is that I call it supply chain management. You have to really do a highly thorough job of coordinating this work so everything shows up when it needs to show up. Because if we're wanting to bathtub the fifth floor, we got to make sure that the exterior closure's there and that it's in place, that we've got the floor materials down to do that, and that's going to connotate that a highly regulated construction schedule. There you go.
All right. So we came up with a set of kind of pre-planned questions to get this going, and then we'll open up to the audience with questions that you might have. So the first question is actually for Chris. We kind of want to do the architect, engineer, contractor, concept here. So Chris Patano, architecture side of things, how does the mass timber material affect your design intent?
Because we're so focused on mass timber, but we don't want to be completely unreasonable when we're looking at projects for our clients, we look at it a couple different ways. Clearly, to execute a mass timber building for a public agency or a private client, there has to be a direction from pretty high up in the organizational chain that somebody wants to do mass timber. So if you have that mission at the beginning of a project, clearly that opens up a lot of doors and lets the design team really dive into material options. Do we use CLT? Do we look at DLT? What makes the most sense for the project type? Oftentimes we're looking at both because they each have different advantages and disadvantages. So that right out of the gate is primary importance, that there's a clear mission to deliver mass timber. That's not always the case, though, and we've managed to have a lot of success with bringing that to the table. So the next level is you learn about what your client's interested in from the architecture side. You start to understand the program and the performance requirements. Maybe you see an opportunity for mass timber, and you can make a presentation to the owner about how there are advantages to that. An example that Ethan's very familiar with is at the University of Idaho. They needed to build a basketball arena athletic arena for about 50 years, and they could not figure out how to do it. And I was working with the university on an all-wood classroom building for their College of Natural Resources, where it was a locally sourced building out at their nursery. No material traveled more than 70 miles. And it was all Idaho wood products, so that was the mandate from the client on that project. The learning curve on that classroom project dovetailed with this resurgence for this need for this athletic facility. And taking what we've learned, and now this was 7 years ago probably, so pretty early on in the mass timber timeline. We went into the athletic director and the president's office and basically said, we know how you can move this project forward. And we said, mass timber is the way to do it. And so that's an example of how the material can form a mission, and the mission can provide clarity to the project, and then the project can gain support. By building the arena out of wood, and especially locally sourced wood, suddenly the question went from why should we build this arena to how fast can we build this arena? So the material choice has some interesting nuances. It can provide a mission, especially for public projects, to garner support. and build that momentum you need to make a project forward or move a project forward. It can also be as basic as I originally said. If it's going to be a mass timber building, you just dive into the options and start to research what is the best fit for the program and the client, and as you mentioned, material availability and functionality.
Any of you want to add to that? Dean, Troy?
Yeah, I guess I'd add, it's interesting hearing you talk about that, because I agree. I mean, I think there's definitely a mission case for mass timber, and it's one of the things that really draws me to it, and as an individual, and as a commercial builder. Every building is a business proposition, right? So we're oftentimes, and I was having this conversation with a client yesterday, they're building for a business case. So what's the is this and historically it's been a premium product. So at a commercial level, so without a mission, without the mission behind it, the developers are looking like, well, why would I do this? Sometimes that can be driven by you have a client that's interested in that type of a building. But I think what I feel like, and I guess time will tell, is that that's transitioning. Is that we're at a point now where the cost doesn't have to be a premium. I think you have to look at these jobs differently. You can't look at them like hey, this is how we build concrete buildings, so I can just substitute wood and it's a savings. I think there's more of an integrated approach. But I think with that kind of approach, I think as moving forward, we're seeing, especially with the more suppliers and the more variability in products and more expertise in the engineering community, these are going to become much more mainstream, and the mission is going to follow.
I guess, yeah, the only thing I'd add there is kind of the part that's kind of hard to quantify is the community impact, because we've seen on some of our larger projects, as soon as the community knows that it's a timber project, it's actually received in a more beneficial light. We've had a couple of community outreach meetings, and people are excited that it's a timber building, even though it's a taller and larger building in their community. They're excited about it, so it's a differentiator for sure.
I would completely agree. There's an aquatic center that we're working with the city of North Bend on, and similarly, you'll find this in almost any community in Washington. There's a timber legacy, a timber history, and if you can pull that history into the project, you find that community support really swells and rallies behind the project. And I think, add, from a material standpoint, I mentioned the success of the Idaho Arena project. There's several projects that we at Patano Studio have pursued with the state level. I've showed Ethan the proposals where there are, higher education buildings in cities like Everett and other communities around the state where the state has asked for a 4 or 5 story classroom building. There's a budget, there's a pre-design, it's all worked out. And in our proposal, we've actually gone in with our timber suppliers and engineers, and we've put the whole project together in mass timber and submitted it and submitted budgets and showed how we could meet their program, how that ties the project into a community more tightly. And we haven't even gotten an interview. And you look at the state's mission and all the good things that are happening, and you feel like there's still, so there's still a latency, there's still a disconnect. And I would agree, I think we're over that hump. I actually think we're over it. But I would definitely like to advocate, and I know there's a lot of people out there doing a lot of good work in this area. We have a lot of opportunities to take our traditional buildings and systems and move them into this mass timber technology. And I think we're at that crux of it happening. But there are a lot of very recent examples that we have particularly pursued where at the end of it, you're like, okay, that's fine, we didn't get the project. I'm very surprised that they didn't want to have us stand in front of them and say, how about this? But that interest, I think, is coming.
And I'll add to that. I mean, Chris is 100% accurate on that. It's kind of like, okay, you didn't even want to talk about wood, and it's like you've got this perfect project that actually was a nice rectangular building. It would have fit perfectly, and they just didn't want to have the discussion. Now, I will say UW has taken a different approach to that. WSU has taken a different approach to that. So there are some, university people that are doing that. So we're working on the Foster Business School up in Seattle. the HSCB building up in Seattle, then here in Tacoma, the admin building's looking at it, the dormitory building's looking at it, and then the, starts with an M, I forget what it is, but the M building here in Tacoma is looking at the CLT. So there's definitely...
Milgard Hall.
Milgard, there we go, sorry. Milgard building's looking at it. So there's definitely some people doing, but there are still some misses like happening in there. And so actually kind of Dean touched on this, the entitlement process is now with these new tall buildings, the entitlement process is like you go in, you say, okay, what can my occupancy be? How tall can this building be? And so with this new entitlement process, how does this new tall code affect your projects as you're going through the entitlement process? Like how is that affecting your decisions and opening up doors, closing doors?
I think it opens doors, yeah. City of Seattle, Washington, and Oregon are amazing, and kind of because of the reasons you talked about. I mean, we have our allies in our backyard with John Sue, who is part of that ICC ad hoc Tall Wood Committee, which has been amazing. And it's enabled us to pursue these buildings with confidence, knowing that we can go into the city, have a pre-submittal meeting, and we're not going to get blitzed. I mean, there's still gray areas like Ethan insinuated that we need to figure out with the city, but they're willing to work with us, and that's amazing compared to other jurisdictions that we've interacted with.
All right. Well, since you're talking, Dean, we've talked about the seismic code changes. So I don't know if you guys got that. A mass timber building weighs significantly less than a concrete building. So as Dean showed in his introduction, those seismic forces are going up, and that's directly proportional to how much your building weighs. So again, now that you've got a mass timber building that could up to, I'd say normally I'd say 50% lighter. The wood industry will tell you 75% lighter, but I'd say like after you add the topping slab and things like that, it really is about 50% lighter. But now you're increasing your seismic loads by 60, 70%, but now you can do a mass timber building that's 50% lighter. The impact is less, but do you want to touch on that some? Like how is that affecting like connections and braces and foundations?
Yeah, so like Ethan was talking about the mass, it is about half, I would say, easily. That's on the conservative side. I mean, residential building, you're looking at an 8-inch or 7-inch PT slab, depending on how hard your structural engineer is going to push the design. And then for these type 4C and BA, you have a 2-hour fire rating for that floor plate. So you need to have at least probably a 5-ply, depending on your spans. And then you got your topping slab on top of that. Type 4C, you don't need a concrete topping, so you can go with the dry assembly. It could be less than half. It could be even more of a cost savings. But in general, some of these buildings, what we'll see, because they're so light, are actually going to start to be controlled by wind, depending on where they're located, if they're on a hillside, which is kind of interesting to consider in a seismic, city. And there's other challenges, but again, it's a testament to this group and other groups that are kind of this coalition that are able to push these buildings, educate, and form communities because, like for instance, CLT diaphragms, it's not really an object of question anymore for Seattle. There's a SEAW, Structural Engineers Association of Washington. They have a white paper, which John Sue's already reviewed, and we're using that on 2 or 3 projects. And so, these barriers to entry in other markets don't really exist, I guess, is what I'm trying to say, in Seattle, which is great.
I would just add, we were talking about this at a meeting yesterday where we're starting a project with the Seattle Public School District. They're going to build a school out of mass timber, and we're in the early planning stages. And the question of the permitting has come up several times. I think we're looking right now, the programming's looking at a 3-story structure on Beacon Hill. And the permitting questions come up, and our experience with the City of Seattle and our DLT building and our engineering team's experience with the City of Seattle all basically said the same thing, which I think is important to relay. Officially, you don't get any preferential treatment. Officially, you will not get any acceleration in your permitting schedule, but boy, the people you work with are really excited to talk to you. And you get full enthusiastic engagement and support when you have those pre-submittal meetings and you have those technical review meetings. And as we all know, as we move projects through permitting processes in different jurisdictions, enthusiasm, that's worth it. It goes a long way, and it really helps keep your project moving forward.
So we'll turn to Troy and talk about some of the cost estimating. So now again, the beauty is the building's lighter. Troy can talk about some of the cost estimating that goes into how do you price these buildings. And then what I will say is that we've found on projects is that, so like the First Tech Credit Union, they saved $470,000 on not having to do soil remediation because the building was that much lighter. But, Troy, do you want to talk about some of the cost estimating, speed of construction, lower foundation costs, things like that?
Yeah, I think, lighter's better. It's interesting hearing these kind of numbers, it made me think of the building as a kite or something. Maybe we have to tie it down now differently. But I think the specific to the mass timber, CLT and glue lambs, I think that, I touched on it a little bit, that what conversations I've had, I think that are helpful, is engaging the different suppliers early on in construction to help. I'd be interested to hear your perspective on this, Dean, but to help with species selection, comment on connection details, and then also give you an opportunity to kind of vet the individual suppliers on their ability to prefabricate, to store material, marshal material before it has to come to the project, what their kind of lead times are. There's, so to get mass timber on site, it's a long lead time, 6 months or something like that from when we first kind of place the order, start shop drawings, things like that. So it's a long process to make it happen and get it out there. So in I think each of the manufacturers I've talked to kind of have a little different approach in terms of how they do their panels, what species they can offer, thicknesses of the panels. Their ability to prefabricate, store, geographic locations, things like that. So I know that's an area that we are studying now and will continue to study thoroughly as we look at projects.
Yeah, I think that it's kind of an interesting challenge. It's new for the design community, but I think at a macroscopic level, you start out in conceptual or schematic, and you kind of have a rough idea what the building is and what you can get away with for spans and sizes of glue lambs. But then certainly, as been talked about before, at a certain point, your team has to become integrated, and you're going to need to select somebody, because if you start to dial in on those details, different suppliers, different panel sizes, different, beam shipping lengths that you can enable in your building. So moving into DD, if you're not bringing somebody on board to help, make those decisions, it's going to be difficult.
And from a programming design side, we can quickly understand the optimal spans. We can understand the most efficient use of the CLT or DLT panels, but that rarely aligns with the programmatic requirements of your client. So a school classroom needs to be a little wider than it wants to be out of mass timber. So you lose a little efficiency there. Still works, you just have to go in. It's very easy to wrap your mind around this concept of this, purely rational, super efficient system. And then you have to take a couple steps back and be, okay, this is a classroom building. We have to give a little ground here to make the classrooms work for the teachers. Or another example would be, we're working on a lab building and there's a lab module. And so you need to have a 26-foot span. And it's a pretty hefty span for wood. And so you pay more for the 7-ply CLT, and you've got some big beams, and you make it work. But again, you've got to make sure that you align your materials and your systems with your program. What we don't want to do is start getting a bunch of projects out there that are the rationally efficient wood structures and start hearing from our clients that they don't work very well. So there is, as always with design, compromise.
And I think with what they're hitting on there is you kind of, they're not saying the word, but you hear it's risk, risk, risk. So how do you de-risk these projects from the architect, from the engineer, from the contractor? How do you de-risk that, to the best of your ability?
I think it's that going back to the integrated design team and then just planning everything out. I mean, the design process is front-loaded. You're going through these pre-construction RFIs, and you're going to have 300 or 400. But I'll say we just finished, topped out a 3-story mass timber office. It's about 120,000 square feet, over 500 panels and glue lambs and everything. And we had 4 RFIs related to that mass timber component. And guess where those RFIs came from? the steel to timber interface. The steel was just a little bit off from where the timber was. So, I mean, that's amazing. So but it really goes back to just pre-planning and making sure that, everything's coordinated. It's not just clash detection, it's actually modeling out the building and how it's going to be built too. So that's how you can try and avoid risk.
So I'm a big believer in the integrated approach, and I think selection of key project partners and bringing them on early is really important. Not just your mass timber, but key subcontractors. One of the risks I think when you talk about high rise and mass timber is that there's very little experience in the industry in terms of completed projects, and so you go talk to a mechanical contractor or an electrician, and a lot of this stuff is kind of is new to them. Now, smart subcontractors are going to understand this, and they're going to do kind of what we're doing, and they're going to learn and integrate. But you're looking for a couple of key things that you've kind of heard me talk about. One is their ability to kind of work in an integrated team, their ability to work with technology, because this is how we're solving and managing a lot of this risk is by this integrated design models and the use of building information modeling. Fabrication direct from the model is really important. I mean, these panels are highly precise panels. I mean, they're fabricated to a millimeter or better sometimes. And so so that means that everything that goes in and around them has to have a similar kind of precision to it. So all that has to be thought through. So subcontractor community and kind of just experience in the field is a risk item. I think weather is a risk item. And I think that at least in our neck of the woods in Seattle and Bellevue, there's a lot of inspector preference in terms of how to do things. So the building inspectors kind of are something we need to kind of bring up to speed. We're very accustomed to having building inspectors come out and they'll look at a UL detail for a certain condition, you go, no, we're not going to build it that way. You're going to do this, and that's easy if you're in a steel building with drywall details. Now when we bring a whole new deal and a whole new program out, they're going to have to go through a similar learning curve. Weather, I think, everybody that was here in January, you kind of paints a picture. We're digging 2 holes and they were bathtubs. We were doing everything we do to pump water out of them. So that's a big risk item, and you've got to really have a tight plan for these high rises, and particularly something that's as weather sensitive as you have with the mass timber and the fire protection requirements that you need to pay attention to. So those are just highlight risk items there.
Yeah, and I'll add on the BIM modeling and the integrated design team, again, can't be stressed enough, and make the additional point that the fascinating thing with the mass timber components is you could always draw in your model this incredibly high level of precision that would not be achieved on site, and then you'd have these RFIs because things really didn't match up. Well, now we're putting together buildings where that precision is achieved on site, and it all does go together, and so it really reduces those conflicts in the field. I'd also bring up for our clients, schedule and cost, of course, right? So the risk in the schedule, the risk in the cost. So you want to show the schedule benefits of mass timber. Also, you need to show the potential pitfalls like January, because that was an eye opener. We're glad we didn't have any big wood structures out in the weather in January. And then cost, just having accurate cost models. We've mentioned in some previous conversations that a lot of the cost estimators that we all use are not structured to factor in the schedule benefits of mass timber. And so you need an experienced contractor or somebody that's worked with it that can show the client where those cost benefits and those schedule benefits do come into play, because if they're missed in that initial cost estimate, you're going to have a really bad day, and you're going to have a bad day with your client because those cost benefits are not going to be realized in that cost estimate that you see.
And I'll add what Chris just said, because funny enough, I was up here. So I live in Portland, and I spend 2 weeks in a hotel in Seattle. That's my normal job. And so I was up here all last week and Monday through Thursday this week. But literally last week, I had 2 cost estimators, 2 clients that said, hey, can you get in touch with our traditional cost estimator, because we don't think they're pricing it correctly. The clients already have enough experience with the contractor that knows what he's doing, and they're getting a different answer from their contractor, and then from the cost estimator. And sure enough, we talked to the cost estimators, and they're not taking the time savings into account. And that can play a huge role. They're not reducing the labor force, So again, most of these mass timber buildings, 5 people is a good number, 6 people, 7 people sort of thing is probably the max you're looking at to do the mass timber erection part of it, and they're still trying to throw a crew of 8 to 12 people on it. So things like that can play a role. So with that, we want to open up to the audience and see if you have questions. And then to clarify, if you raise your hand, Lindsay will run around with a microphone. If you got questions, and in that meantime, while she's finding a question, I'll let you know, I tell you how old I am. My first buildings were drawn on paper. I mean, it was a scale and it was drawn with pencil, and then you went to the blue line machine and made blue lines and stuff. So, nowadays the BIM model, we are drawing the building in the computer, sending it to the engineer. He's drawing that in the computer, and then they're sending it to the MEP or electrical, and they're drawing their components in the computer. And so it's one integrated model. We're not handing off sheets of paper and then someone's going through and trying to lay up sheets of paper and put a bum wad over it and see if you tracing paper, see if you can see through it, and things are hitting. This is all done now in a computer model. And then sheets get produced to go out to the job site, to go to the suppliers to do cut sheets and things like that. But that's the integration that we're looking at today. So any questions? Yeah.
So I hear a lot about the VDC standpoint on the models. My question is the transition. Historically now we have design models and we have for construction models, and there's a difference. And especially from a coordination standpoint, are we seeing a transition from the for construction being developed in the design, or is there still a transition of design model to for construction and a recreation for the CLT, specifically for the contractors to use in the field?
That's a good question. So at Patano Studio, we made the commitment 4 years ago to eliminate the design model. So we banned certain softwares that might be, really easy to start doing your design iterations. And I was impacted as much as anybody else because it was my go-to design tool. But we just committed to the model as the model, and we are building 100% completely from day one what you term the construction model. Well, that's a great question.
The question was, does that change your fee?
Yes. So, for those ears out there that have influence on things like this, the other thing we need to catch up on is the standard fee schedules and the standard allocations of fee percentages do not reflect the way we are now working.
True that.
At all. And if you throw into that mix that most projects have gone design build, they're even further off because the project is even more front loaded. So yes, we're doing, I usually draw this with a chart. The classic 30, 60, 90 AutoCAD production, the curve ramps up. Okay, CDs are due. Okay, now we're done, right? The BIM model production is a big arc at the front and a gradual curve towards construction documents. So you invest all that time up front, you completely build out the model, the first coordination drawings that go to the structural engineer, and if you have a contractor on board, they're everything.
Excuse me, could I add?
Just continue adding to that model as you move forward.
Okay, could I ask one more question that ties in with that? Could you speak to the software handoff now between, you're talking design and construction, how about manufacturing, the digital manufacturing piece in a CLT plant?
So we, similar, I guess we could probably do a whole presentation on VDC and BIM modeling. Our approach is, I guess simply stated, we build the building in the model, and then we build the building for real, right? And if you look at, if we do that right, and we usually get it right, we're not perfect, you can go out and take pictures of the building and look at your model, and they're one and the same. And now we're doing VR stuff, so you can put on goggles and you can walk in, and even in that where the model will even transition itself into uncompleted areas. So you can say, this is what this looks like, and then we'll have a virtual reality component where the model will overlay an image, and now we can see a complete building. We use, everybody kind of has their own deal. We use what's called a federated process. And think of it like the United States, the Federation of States. So all of our stakeholders, design team partners, subcontractors, manufacturers, because we want to build from the model, we want them to model their work in their native software. So a lot of the CLT panels, they like Dietrich or something like that. They'll have a software that they like to use. So we'll have them model their elements that way. MEP subcontractors like to use like AutoCAD MEP. We'll do a lot of structural elements in Tekla, like structural steel or something like that. And then we'll integrate it all into using generally a Navisworks package. And we clash detect it in that environment. So the model is always kind of evolving. And we look at our stakeholders, our partners, like the design team, that say, just don't take this wrong, you're just another partner. So we take your structural model, take the architectural model, and we clash it. And that's one of the reasons why this process lends itself to kind of integration, is because we all sit around, we're all looking at each other's work overlaid, and you can see what doesn't work. And then you in a collaborative fashion, you say, oh, okay, well that detail has to change, or guess what? There's this big element and it doesn't look great, and the design team will have an opinion about that. But yeah.
All right, do you want to do one last question, or you want to call it? Let's do one more question from Russ in the back of the room.
Yeah, hi there. You guys were talking about some of the cost and misestimation based on labor and time. The other thing that I've seen a lot of, and I'd love to hear you guys' take on this, and Ethan, we've worked on this a couple of times, where the design was overbuilt. For instance, there was 7-ply where it was going to be 5-ply, or there was something like that. I'd just like to get your guys' take on some of the designs that come out that could make something financially not doable, and how do we reach out at the very beginning so people aren't designing things that aren't going to work from the start, and then getting feedback out to the marketplace, because the things that we hear are that, well, it's not cost effective, and it's all these little things. So if you could just touch on that to any of you up here.
Yeah, and I think that's kind of what you heard today from this panel, is you've got to now start integrating the team. You don't let the engineer just go off and run things. You don't have the architect that says like, oh, I have to have a 30 by 30 grid. It's like, okay, well, if we're going to do a 30 grid, can we add an intermediate purlin to take that 7-ply down to 5-ply? I mean, I think that's...
Yeah, I'd similar see it where we get brought on for SD or DD, and we'll send out a set, and it'll get ripped apart by different suppliers because they're trying to edge in their panel dimensions to meet that floor plate. Oh, no, don't work on that grid, work on this grid. Oh, no, that's a bad grid, work on this grid. And so that happens too. But yeah, it's just integrating the team like Ethan was mentioning to make sure that when you do pick a supplier, it's most efficient.
And I guess we got a little bit of time. I would just add, one of the things I think you'll see, we were back, some partners of mine, design partners and I were back in Europe here last fall or winter. And one of the things that I saw that they're doing in Europe that's really cool is that they're doing custom panels and custom glue lamps. So there's not a fixed, they're not fixed lamella thicknesses. They vary species based on the use. They had one mock-up that was a glue lamp column. It was like spruce pine fir. It was like this big, but if you did it out of beechwood, it was like this big, same strength, right? So I think as these manufacturers, our supplier chain kind of gets more up to speed and does more, evolves more and innovates more, you're going to see, I think, more customization of that and optimization of the material.
All right, well, thank you, panel, and please give them a round of applause.